An associate professor. Mhm. Welcome all. I'm James Postigovsky. I'm an associate professor at the University of Wisconsin-Madison. And this is the first meeting of the fall 2023 edition of the Systematic Review and Meta-Analysis SIGS online seminar series. We've got a great lineup of talks for the fall, which if you haven't seen, you can check out the full lineup and get the details on our website, which we've just posted in the chat. It's also, I think in Carlton, correct me if I'm wrong, I think we've got all the our reviews in from the AERA proposal review process. So if you were one of the very kind people who helped with that, thank you. And we're looking forward to being in a position to announce the program coming up in 2 or 3 months. So today, I am really pleased to introduce Dr. Alex Kale. Dr. Kale is an assistant professor in the computer science department at the University of Chicago. He holds an MS and a PhD in information science, also a BS in psychology from the University of Washington. His research focuses on how to design software for analysis, visualization, and interpretation of data while taking into account users' cognitive processes, like the heuristics that we apply to make judgments about visual representations of data in the forms of charts and graphs. He's applied this framework to an array of different topics, from effect size visualization to causal inference to multiverse analysis. And I'm just really excited that he's also turned some attention to thinking about design of software for meta-analysis. He's going to be sharing some of that work today, and we'll follow the usual format for the seminar. Alex will present for maybe 40 minutes or so. If you have questions, clarifying questions, anything to get off your chest while he's presenting, feel free to type it in the chat. We'll monitor the chat and kind of interrupt as necessary. And then we should also have plenty of time for discussion at the end. So please join me in welcoming Dr. Kale.
All right, thank you so much for having me here today. I'm excited to speak with this group. I'm going to go ahead and share my screen and kind of get going here. Okay, so let me just rearrange some things here. Sorry, you know how it goes. All right. So yeah, my name is Alex Kale. I'm an assistant professor of computer science and data science at University of Chicago. The work that I'm going to share today was done in collaboration with researchers at Stadler Henke Associates, which is an AI firm in Seattle, and researchers at Northwestern University. So in this talk, I'm going to show you how software tools can better support research synthesis by emphasizing sources of epistemic uncertainty, and how basically, how do we help people reason with epistemic uncertainty that they encounter when trying to summarize a body of scientific literature? So what do I mean by sources of epistemic uncertainty, and why do scientists care about it when trying to summarize findings from the literature? The scientific process is full of decision points. For example, what exactly should we measure? How should we analyze those measurements? Our answers to these questions determine how we make meaning, and in some of the decisions that we could make are more defensible than others. So this introduces uncertainty about whether our findings are robust to decisions that we could have made. Gelman and Loken famously dubbed this problem the Garden of Forking Paths, pointing out the degrees of freedom that scientists have to inadvertently change the results of their research. Scientists have different ways of resolving uncertainty about what to do, and as a result, the literature contains a mixture of these different decisions. This poses a problem when we want to summarize scientific evidence. We sort of inherit these myriad decisions from other researchers, and we have to decide what we make of them in order to aggregate evidence in a meaningful way. The typical process of evidence aggregation is systematic review and meta-analysis. To recap for folks who are not familiar with these terms, A systematic literature review is a structured process for defining a research question, querying the literature for articles that address that question, and coding each article for relevant information, such as study design, participants, and a summary of findings. Then aggregating quantitative findings through meta-analysis involves gathering statistical information from each study about the sort of results, and then combining these in a model which often estimates an average treatment effect. So at each of these steps, the reviewer makes many of their own research decisions, which in turn impact both their descriptive summary of literature and the results of their meta-analysis. So there's this fundamental challenge of deciding what to do with this mixture of different study designs and data analysis choices, some of which could bias our study results or otherwise make them difficult to compare. But there's another sort of epistemic issue that makes meta-analysis uniquely difficult. Unlike the way that taking an aspirin dulls a headache, not everything that we measure in science has one fixed treatment effect for all individuals in all settings. And methodologists, like many of you in the audience today, spend a lot of time thinking about how to model this heterogeneity. But for many practitioners, the proper response to heterogeneity is somewhat unclear. They don't always know what to do. And for these reasons, evidence aggregation is like building a house of cards. There's a whole lot that has to go right for us to make valid inferences. So as a running example, I want you to consider a corpus of papers investigating the effect of social robots on mental health in older adults. So this is from the sort of human-computer interaction literature. Some of these studies have potential flaws, which might make us doubt their results, and we call this issue risk of bias. Some of these studies measure different things, raising questions about whether their results should be compared, and we call this issue measurement consistency. And some of these studies were run in settings that are so different from the target context that we'd like to make an inference about that it may not make sense to generalize from them. And we call this issue applicability. So in order to meta-analyze this corpus on the effect of social robots on mental health in older adults, or more broadly, the effect of any intervention on an outcome of interest, a scientist must identify these issues and reason through how they can be resolved or propagated to inform statistical inferences. We call such sources of such concerns sources of epistemic uncertainty. So this is not like the quantified uncertainty that we typically visualize as distributions, like confidence intervals, for example, but rather the hard to quantify uncertainty around those numbers, the kind of uncertainty that results from our not quite knowing what to do about our epistemic concerns. So we derived this sort of grouping of sources of epistemic uncertainty through a content analysis of quality of evidence assessments for research synthesis, including the Cochrane risk of bias checklist, the grade criteria for observational studies, the Newcastle-Ottawa scale, the P-CUTS framework, and various other things of this nature. Although there were many such assessments and handbooks that emphasize how to handle sources of epistemic uncertainty, surprisingly few software tools for meta-analysis require users to grapple with these issues or do anything to guide research synthesis toward the resolution and propagation of these sources of epistemic uncertainty. Instead, what most meta-analysis software does is focus on producing a numerical effect size estimate. And to me, this makes a lot of sense, given the scope of these statistical tools. They're trying to, help the user find the right sort of quantitative method for their data. But I think that by not making these sources of epistemic uncertainty sort of like this explicit thing that you're guided to reason about and requiring people to grapple with it, not just making it sort of an optional step, this can lead scientists who conduct meta-analysis to average over meaningful sources of variation, achieving results that can seem authoritative, but can also be hard to interpret or potentially misleading. So there's sort of a big failure mode here if we don't think about these things. So we tried to address what we saw as a gap in the design of existing meta-analysis software. We created a prototype system called MetaExplorer, which facilitates exploration of what scientists might infer when aggregating study results from a body of literature. So here what we see are a collection of results from a literature review and a visualization that's modeled after a forest plot. Using MetaExplorer, scientists can see concerns about quality of evidence by sort of mousing over study results that they flagged. And they can interactively add or remove study results from their analysis to see how this impacts their overall effect size estimate, which is shown in the bottom row of each table. So this is sort of like the culminating view of the interface, but I want to talk about how we get here and how we ask people to sort of consider these myriad sources of epistemic uncertainty on the way. So in MetaExplorer, we make epistemic uncertainty a first order consideration by both eliciting sources of epistemic uncertainty as users are reviewing scientific articles, and by guiding users through procedures for propagating these concerns to inform statistical inferences. As a human-computer interaction researcher, I work on software prototypes like this, not necessarily to solve a giant problem in one go, but rather to experiment with new design patterns for tools, and especially to engage the people who might use them about the benefits and drawbacks of various approaches. So in the next portion of the talk, I'll give an overview of MetaExplorer, specifically how it handles epistemic uncertainty. And then I will sort of, along the way, discuss the rationale for different design choices. I'll reflect on what went well and what didn't. I'll summarize what we learned from talking with experienced meta-analysts about the tool. So the first step in MetaExplorer is to scope a review. So to start, this means defining a research question in terms of an intervention and an outcome of interest. There should be a video that's playing, sorry. And in our social robots example, we chose an outcome variable, depression, which is commonly measured by studies in our corpus. At this stage, MetaExplorer also asks questions about inclusion criteria for studies in the review, expected confounding variables that should be controlled for, and the target context about which the user would like to make an inference. Documenting these helps the user stay on track during the review. And if the user changes their mind while they're reviewing the literature, they can return to the scoping view to make revisions. The idea is not to pre-register these decisions, but to document them somewhere inside of the tool that the user can reference back to, and where this information can be sort of explicitly stored alongside information about studies in the corpus. So after scoping, the user moves on to a review management page where they can upload papers, monitor their progress, and navigate between other views in MetaExplorer. The tool is pretty feature-rich, so rather than showing you every single thing that it does, we're going to focus for today on how sources of epistemic uncertainty are elicited and propagated through the workflow. MetaExplorer elicits sources of epistemic uncertainty during what we call evidence extraction. This is a stage of the workflow where the user reviews each article in their corpus, answering questions about how the study was conducted, for example, who the participants were. Questions in the evidence extraction form are then linked to quality assessment items addressing epistemic uncertainty. For example, whether exclusion or attrition from the study sample may have resulted in unbalanced treatment in control groups. So this is an example of a risk of bias type issue. The idea of linking questions across these two forms is to raise these epistemic concerns at the moment of initial reading, when our pilot testing indicated that potential users were most skeptical of the studies in their review. In other words, if you sort of breeze past these things when they first occur to you, you're less likely to write them down at all. Like when you come back to the study, you're digging less into the details, you're kind of more likely to sort of take the summary of findings that you find somewhere in the paper at face value. So that was sort of the rationale for building it in this way with these multiple linked forms. We had other quality assessment items addressing applicability concerns, such as whether the experiment is representative of the target setting where we might like to apply this intervention that we're studying. So here there's a concern about the study being run in a nursing home, whereas the scientist conducting the review is wondering about older adults who are living more independently. We, as I mentioned before, synthesized these quality assessment items based on a survey of existing quality checklists, aiming to sort of concisely cover the epistemic concerns that can typically threaten the validity of a meta-analysis. So we tried to cover sort of a superset of the types of things that we saw come up in all of these quality assessments without sort of introducing redundancy into the form. We aimed for something that was pretty concise. Unlike previous tools, MetaExplorer unites these quality assessment items with a standardized output format, and it requires quality assessment before marking a review complete. So we felt that it's important that this isn't an optional step. But I also want to take a moment to talk about why did we create our own quality assessment? Why did we need to go for something with this sort of standardized output format? Basically, existing quality assessments produce a variety of outputs that can be difficult to collate and reason across. So, for example, the grade criteria for observational studies produces outputs that are in this sort of like ranking system where you have like a number of stars assigned to a study. And that's very hard to compare with the output that you would get from a tool like the Cochrane risk of bias assessment. So we were trying to sort of streamline this and create something where you could sort of more easily collate and compare these things, regardless of what type of research design you were dealing with. At least that was the intention. So for each quality assessment item, it's of the form, was this particular thing an issue in the study? With response options, yes, no, and not sure, plus a text box where users can sort of document their rationale for why they're treating this epistemic concern in this way. This acknowledges that these judgments are highly situational, that they often involve shades of gray, and that the information that we need to make them is not always reported in a paper. So after reviewing this whole corpus, the user moves on to a triage view, which provides tables that group epistemic concerns based on what the user should do about them. So recall these three sources of epistemic uncertainty from before. Each of them receives a table in MetaExplorer, collating relevant information from the evidence extraction and quality assessment steps. When the user suspects risk of bias, they can flag a study so that they know to remain skeptical of it later on. When studies measure different things, the study results are meta-analyzed separately. The user can sort of group studies into separate tables and say, we're not averaging across things that measure different things. And then when study results are of doubtful applicability to the target setting, results are shown in subsequent summaries, but they're not meta-analyzed. We're not averaging together with evidence that might be more relevant to the setting we're trying to make an inference about, but we're leaving it there so that the user can sort of be aware of it. So for an example of this sort of triage process, here we can see the triage table for risk of bias in our social robots review. Note that the uncontrolled covariates, the covariate adjustment set, is sort of hearkening back to the things that I said I was going to look for at the scoping review, or at the scoping view, right? The sort of things that a priori I thought needed to be controlled for in a study. So each relevant quality assessment here has a column, and each study result has a row. And we can see in this table, as I scroll down, the risk of bias concern that I left for this Robinson et al. Study from before, where things I needed to know just weren't reported. And so I've decided to put a flag on this study and write a note summarizing my concern. And so this flag and note are what are going to be propagated forward to the next stage of analysis. An early implementation of MetaExplorer did not have a triage process. We had opted instead to show epistemic concerns alongside statistical information in more of an open-ended exploration interface, similar to the kinds of visual analytics tools that you would see in sort of the business intelligence world. I want to talk a little bit about why we did not keep that more exploratory version of the interface and kind of show you a mock-up of what that looked like, because unfortunately I don't have any screenshots or videos from the time. So here's kind of what that exploratory prototype looked like. On the right, we have something that's sort of meant to resemble a forest plot where each row is a study result. And on the left, we have sort of a set of buttons, one for each sort of distinct epistemic concern that you might have identified in this review. So in addition to being able to sort of toggle studies to include them using the buttons embedded in the right side of the forest plot, in this more exploratory view, the user could also sort of drag study results between different groups of studies to sort of like reorganize them. And they could click the buttons in the left sidebar to highlight epistemic concerns that were raised during lit review. So imagine, for example, that the user clicks on a risk of bias issue, like non-random assignment to treatment and control conditions. Here, the studies where I said, yes, there was an issue, or I'm not sure if there was an issue, are highlighted in red and yellow, respectively. And I could see the notes that I left about these things by sort of mousing over each study result. So I'm no longer sort of like going through and reducing down my uncertainty, the set of things that I'm considering, to the things that I really expect to play a role in impacting my statistical inference. I'm just dredging all of it up at this stage and letting the user sort of click around and explore what they surface during their literature review. Consider another example. Imagine that the user clicked on this measurement issue. Like some of these studies used cluster randomization and others didn't, where cluster randomization is common in the education literature, where treatment conditions are often assigned to like classrooms or schools rather than individuals. The user should see something like this, where all of the studies that are designed with this additional source of variance in the effect size estimate get grouped together. And if not, the user should regroup these results based on this difference in what is measured. So this is sort of what the early prototype without the triage view looked like. And when I showed this prototype to expert meta-analysts early in our design process, just sort of getting informal feedback, they said that this more open-ended version of MetaExplorer made the epistemic concerns really overwhelming, like really hard to make sense of the evidence with any confidence. There were also concerns about post hoc inference, where users could sort of choose how to handle these epistemic concerns after they're seeing the meta-analytic results, after they're seeing how these things sort of shake out when they group them in different ways. So there's too many degrees of freedom here. So we added this triage view based on requests for more procedural ways of handling epistemic uncertainty. And I think that's a really big takeaway from this sort of design study, that people really wanted that. This entails sort of locking in the study groups and flags before we're actually seeing the forest plots and performing sensitivity analyses. So sort of revisiting what that final culminating interactive visualization looked like, which I showed briefly earlier in the talk. These are modeled after forest plots. They're essentially tables showing one study result per row, including summary statistics and a visualization of the estimated effect. Recall that the bottom row in each table is showing us the average treatment effect estimated by a meta-analytic model, which in MetaExplorer is just a random effects model for each table. It was fairly straightforward on the modeling side. MetaExplorer's visualization consists of multiple such tables. So we get one of these for each study group that the user has sort of put together during the triage step. In this view, I can, as I showed before, kind of mouse over these icons and see notes that I left myself about risk of bias concerns. I can also perform this, sort of sensitivity analysis. What happens to my result if I add or remove, the study in a given row? One of the more sort of novel things that we did with this, because this is basically an interactive forest plot, was using quantile dot plot visualization to show sampling distributions. I realize this might not be familiar for some of you. We were following prior work in the visualization literature and in cognitive psychology that finds benefits of framing probabilities as frequencies of events. So this is sort of a state of the art and uncertainty visualization type of thing. The idea behind quantile dot plots is that you're showing, in this case, 20 evenly spaced percentiles of the sampling distribution in each row of the forest plot. And in MetaExplorer, we can prompt users to think about each dot as one of 20 hypothetical replications of the study in question, which enables users to interpret these visualizations by counting, right? So in this bottom row here, I might say, okay, well, 2 of my dots are on the right side of the 0 line. So that means that, in 10% of my sampling distribution is showing an increase rather than a decrease in depression when you introduce social robots. So that kind of provides a nice way of interpreting the uncertainty in the sampling distribution. All right, so that's sort of the exposition of MetaExplorer, the tool that we built, the design choices that we made. I'm going to turn now to talking about evaluation of software like this, which ironically is a methodological challenge in itself. I'm going to talk about a few things that we considered doing and why we didn't, just to sort of contextualize, why do you evaluate software the way that you do? It's hard to definitively say whether people produce better inferences with a tool like MetaExplorer, because the ground truth is unknown and potentially unknowable, right? Like if we knew the true effect size for an intervention, or we could discover it through a single study, we wouldn't need tools for meta-analysis. And this means that it's hard to evaluate not just tools for meta-analysis, but really any sort of statistical software on real data with a controlled experiment, where we want to be able to say, like, is there less of a bias in my ability to form a statistical inference, or am I making more precise statistical inferences? It's very hard to say that without having a reference for what that ground truth is. So this is a problem that you encounter all the time when you do human-computer interaction for statistical tools like I do, how to define the ground truth. So another option we considered, sort of having a controlled experiment, being kind of off the table, was recruiting scientists to use the tool for their own projects and presenting these as case studies. This would have been great because we could have learned a lot by having people go through the whole workflow that we designed. But this would have required a huge time commitment from participants. Just to run a small meta-analysis takes hours and hours. And then there are also sort of the perceived risks of picking up a tool that's outside of your typical workflow and using that, the sort of threat that you might have to sort of like redo some labor in order to get something ready for publication if the tool doesn't do exactly what you need it to do. So we started recruiting participants during the COVID-19 pandemic, and we realized that this case study strategy was also not going to be feasible. What we ended up settling on was what I call a guided tour interview protocol, where we demonstrated MetaExplorer's features and workflow for experienced meta-analysts, and we interviewed them about the benefits and drawbacks of this approach, and what they want from a tool like MetaExplorer. So these interviews were recorded in Zoom, and we performed a qualitative analysis of interview transcripts to characterize participants' impressions of the system. So this type of qualitative evaluation is rather common in human-computer interaction research. I'm going to share a bit about what we learned talking with experienced meta-analysts. Participants viewed the interface as a partner in the analysis process, whose role was to promote skepticism by raising these sources of uncertainty. So for example, one participant said, I would model this tool to be a grouchy reviewer that's constantly convincing me not to publish the study because I don't have a corpus that's good enough, or I don't have enough certainty. Another participant appreciated that the tool guided them to consider applicability of results as a core criterion. He said, now that I've seen this, I really think this needs to be an integral part of meta-analysis. I have to admit that in meta-analyses I've been involved in, these conversations didn't come up that much. I don't remember having these deep, long conversations about how studies contribute to making policy decisions for a particular situation in a particular context. So this is speaking to the importance of emphasizing applicability concerns. Based on this feedback, we see some exciting opportunities around design patterns that are more conversational and collaborative, trying to sort of push our interfaces more in this direction. And I'll talk about this a bit more as the talk goes on. Another major tension that surfaced during our qualitative analysis was that scientists have idiosyncratic preferences, and that scientific domains have different standards around both quality assessment and meta-analysis, just the overall approach to it. People want different things. So in MetaExplorer, we created a general workflow with the aim of accommodating scientists across domains. And on the one hand, participants really liked having a procedure to follow. One participant said, I typically think about epistemic uncertainty more manually, less systematically. It comes up all the time, but the tool allows you to have a very strict and very formal way of dealing with it. However, our approach to streamlining this handling of epistemic uncertainty also raised concerns that the tool was of limited utility for some research communities. One participant said, would you make this more flexible for people who are in engineering or ecology and evolution? Because our experiments and studies are very much different than social psychology. Like a lot of ecology and evolution is observational. This is similar to something that another person said, that the tool was sort of more geared towards experiments, couldn't really accommodate qualitative evidence of the variety that we gathered in evaluating this tool. Other participants in the biomedical sciences seemed admittedly somewhat alarmed that MetaExplorer didn't support standards like Prisma, Mutos, or P-codes. So even though these were an inspiration for us when designing the tool, and we tried to capture these standards in spirit, there was sort of this demand that users be able to use that established standard within the tool, right? Like if you're going to publish in the medical community and your colleagues are expecting Prisma and you're using a tool that doesn't implement that, it's sort of a non-starter, right? So this is something that I didn't anticipate, but that people were really adamant about. So we suggest that these sort of challenges around customization could be resolved by sort of adopting a design pattern where users can author their own research synthesis workflow as templates, right? That they can then sort of select from a menu or design their own custom form questions and compile a version of the tool that is going to be tailored to their needs for their particular review. This is similar to the sort of form customizations that are currently supported in commercial software like Distiller SR. But I think in a tool like MetaExplorer, it requires this additional degree of sophistication because we have this triage process, we have this guided workflow. And whenever you create a new question or you decide which questions are going to be in your form, you also kind of need to decide how that information is then going to be propagated through the workflow. Like, which table is it going to end up in? What should you do about it if you are convinced that this is really an issue? So, work on how to sort of author workflows themselves is sort of a promising future direction. Before I close and sort of summarize the challenges that we sort of stumbled upon in this work, and elicit feedback from you all about what is most useful to work on next, really. I'd like to give a bit of a retrospective on work that led us to build MetaExplorer the way that we did, sort of the challenges that motivated us and the degree to which we feel that we addressed them. So when I was first wading into this research topic, I did some formative interviews with scientists who do systematic review and meta-analysis. Specifically, I recruited 11 professional researchers and asked them about their approach to making research decisions in systematic review and meta-analysis. So this is kind of hearkening back to that researcher degrees of freedom, garden of working paths type of framing that I started the talk with. Specifically, I interviewed 4 professors and 1 postdoc at the University of Washington Medical Center, 2 PhD researchers at the Seattle Veterans Affairs Medical Center who work on treatments for post-traumatic stress disorder and substance use disorder. And I interviewed 4 scientists at the United States Naval Air Warfare Center Training Systems Division, which is quite a mouthful. That's NOC-TSD. Basically, we interviewed this last group of participants because we built MetaExplorer as part of a contract with the Department of the Navy. The Navy were interested in streamlining the process by which their scientists reviewed the scientific literature and made recommendations on training programs for the military to use. So they're making recommendations to sort of higher ups in the Department of the Navy. And it was pretty interesting to talk to those folks. I'll share a bit about what they said here. These participants told us about some interesting pain points in their existing practices, which motivated some of the design choices in MetaExplorer. One major tension in research synthesis is between exploring possible interpretations of a corpus of studies and guarding against post-hoc statistical inferences. So consider this quote, for example. We'll have suggestions for these different types of analysis we conduct that might split the hair a little bit differently and give us additional information that we can then decide, okay, what is the best way to report this now that we've looked at it both of these ways? Okay, so the notion of splitting the hair a little bit differently to gather information might strike us as rigorous. But at the same time, choosing what to report after trying multiple analyses might strike us as behavior akin to p-hacking. So in MetaExplorer, we sought to enable some exploration through things like sensitivity analysis without enabling users too much flexibility in analysis choices once they reached a particular point. This is why we sort of arrived at a guided process, is to sort of place strict controls on what moves are allowed at different points in the workflow. However, this made the set of operations available in the tool too rigid to accommodate a wide variance in practices across disciplines. So this is sort of a fundamental design challenge when you're trying to build tools like this. Another pain point was that scientists tend to document their rationales for analytical decision-making very inconsistently. We observed that if scientists reported documenting their reasoning at all, it was distributed across personal correspondences and notes and various work documents, and it was never really collated anywhere. It's difficult to reference later in their workflow. So we actually enumerated every decision that participants in these interviews mentioned. And here are some sort of descriptive statistics on their reasoning. We sort of grouped the reasons that they gave in a content analysis, and we saw that scientists give a lot of weight to standards of practice in their discipline, the principle that analyses should be comprehensive, their particular research question, of course, and then various other situational factors having to do with the domain or setting that they're working in. And of course, this is not a representative sample. These are things mentioned by a convenient sample of 11 researchers. But scientists in our interviews were clearly thinking a lot of things that were important to their analysis, but they were not really a part of their evidence spreadsheets. And in MetaExplorer, we tried to weave these considerations of analysis rationale into the quality assessment and triage forms. We tried to give users of the tool clear places where they could write these things down and sort of expect them to be surfaced later on in the analysis where they're going to be relevant. However, this design pattern isn't necessarily appropriate for addressing all of the things that participants in this formative study mentioned, things like limited time and attention, or limited support from tolerance for uncertainty, limited alternatives in what your management is telling you can and can't do in a review process, which is maybe more relevant to people in the Navy or embedded within other organizations than an academic researcher. But nonetheless, one last pain point I'd like to mention is communicating uncertainty. Consider one last quote from a scientist in the Navy describing what decision-making officials expect from analysis reports. Decision-making officials do care about the fidelity of the data. They just don't want a chart on it. If I remember correctly, he was talking about how forest plots show more uncertainty than decision-making officials necessarily want to see in a briefing. But by de-emphasizing this information to sort of like satisfy this lack of tolerance for ambiguity or risk, researchers may be suggesting that inferences have greater credibility than they do. And in MetaExplorer, we didn't really take on this task of rendering communicative visualization since the scope of the project was already so large. However, I feel that this is a major unsolved problem. How are we supposed to communicate the myriad sources of uncertainty and error that contribute to a meta-analysis if the expectation is that the findings will be crisp and simple and inform just a straightforward policy recommendation? That's just not the world that we live in. So this is like a sort of a chasm that we have to bridge somehow. And I think that better tools are part of that. So I'm going to end my talk by recapping what I see as the major open challenges in designing systems for reasoning with epistemic uncertainty and research synthesis. And as I'm doing this, I'd like you to sort of consider which of these resonate most with you, because that's really where we're headed next, is a discussion of these issues. So we just talked about the challenge of communicating uncertainty and findings, especially when people don't want to hear it. Another theme that's been raised multiple times is collaboration. For example, many of our participants asked if we could make MetaExplorer support the resolution of disagreement during dual review. Generally, I think tools can do a lot more to become a part of these discussions that tend to drive scoping decisions, tend to drive the resolution of ambiguity. It's all about your conversations with your collaborators in these judgments. At least that's what I've seen studying this over the last few years. Even if the role of the tool is mostly to raise awareness or to lower coordination costs between people, this is a really important part of this type of work. Workflow customization is another ambitious idea that I mentioned. One place that MetaExplorer fell short was in supporting synthesis for non-causal evidence, especially for qualitative data. How do we tractably support this sort of wide variety of research designs and approaches to synthesis that exist across the sciences is sort of an open question. On the more technical side, maybe we can improve the way that we respond to the particular types of epistemic concerns that MetaExplorer tried to deal with. Can we do more than just flagging studies as a response to risk of bias, especially when multiple sources of bias might interact with each other? So for example, I've been reading about this topic, and I've seen some proposals to sort of subjectively estimate the magnitude or at least the direction of bias induced by a study design choice and to attempt to correct for these when modeling. However, I've read some critiques of this approach from statisticians like Standard Greenland that rightly point out how messy it would be to sort of mix evidence with these kinds of subjective estimates, which are likely to be pulled from the air in some cases. So I feel that we can do more, but I don't know precisely what. And maybe that's something we can talk more about. Another thing is, can we support more sophisticated modeling approaches, such as network meta-analysis or approaches to partial pooling of variants that are contingent on study design choices? I know there are many people who are focused on this as a statistical problem. I am sort of referring to it in this case as a cognitive problem. For me, this is about how to help software users compose a complex model specification based on a wide variety of possible study designs that might need to be handled differently. So our response to this in MetaExplorer was really too simplistic for some practitioners. We were merely grouping and excluding studies to handle heterogeneity. But I think guiding that thought process to get to these sort of more sophisticated modeling approaches is also an interesting direction for future research. Relatedly, can we respond to applicability concerns without just ignoring evidence? Are there ways of helping scientists reason about the shades of gray in applicability, or somehow conceptualizing the distance between a study and its target context, such that we can do more than just say, we're not sure if this one's relevant to your situation, but here it is. It's off to the side for you to look at in case you want to. All right, and last but not least, I see interoperability as an important hurdle for adoption for this type of tool. After building this system and talking to scientists about it, I am beginning to question whether tools for systematic review and meta-analysis should try to be all-in-one platforms like MetaExplorer or the Cochrane suite of tools. I see people shaking their head like this. There are important degrees of freedom in the review process that we didn't even manage to capture in MetaExplorer, despite all of its complexity, such as variation in literature search strategies, what search terms you're using, things of that nature, not documented in the tool. We also struggled to get people to use MetaExplorer. And I think that this is in part because there are some gaps in its capabilities, and the pandemic made it hard to recruit people. But really, I think it's even more so because scientists don't want to move outside of their typical workflow or walk away from tools that they're already familiar with, that already work well for their purposes. So one of the things that I've been wondering about is whether we can apply some of these lessons learned from MetaExplorer to build tools that are more interoperable with general purpose tools like Excel or RStudio. Yes, we'll lose some ability to account for like every single degree of freedom, but we might still be able to provide tools that sort of glue together and guide this overall synthesis process while delegating portions of that workflow to tools that are already successful. Okay, so if possible, I'd like to take what I've learned and sort of refine it into a tool that folks like you might be more inclined to rely on. And to that end, I'd like for us to spend some time discussing which of the challenges presented around epistemic uncertainty seem most pressing in your work and why. And then how do you want a tool for reasoning about epistemic uncertainty to integrate into your existing workflow? Thank you for your attention.
Great, thank you very much. And we've got a fair amount of time for questions.
How did we do on time, by the way?
Great, we're at 11:43 by my watch. So we've got good 15 minutes or so for questions. I mean, I'm a little bit my first reaction to this question, I'm wondering if Terry has the same reaction, is all of the above. We need it all, man.
Although I do want to, I don't want to take up the thing. I do want to say, Alex, that I think that as someone who's taught meta-analysis to a lot of people and who thinks about this stuff, like having a more disciplined way of thinking about this epistemic uncertainty is a huge contribution. Because most of the time, and I read a lot of meta-analyses in the social sciences, we do the risk of bias stuff. Maybe we have a little bit of like, oh, there's a few studies aren't good. We report overall, what that is. And for each study, then maybe we add it into our analysis, and then we kind of walk away and not talk about it anymore. And so a tool that forces you to be more systematic about it and forces you to really think about what the implications are is really a big contribution. So I'm just going to say that and be quiet.
Thank you.
I can read the questions in the chat. Rebecca Steingart has a question. Is there a tension between benefits of uptake based on interoperability and the increased likelihood for human error when switching between software and tools?
Yeah, it's a really good question. I think you have to worry about, human error with like anything that we're doing in the sciences. I think it, probably does happen more than we realize. I think there are ways to approach interoperability where the sort of like transition between tools is like mediated by the technology. So like maybe you use a web interface to sort of like identify the scope of your review and to sort of build sort of a template for your extraction form, but then you do the evidence extraction in a tool like Excel that you're like more accustomed to using. If you then are going through your review and you realize that you need to sort of add something, I think the very manual and error-prone approach would be to like, copy things back and forth as the human user. But I think there are probably ways to just like make these tools talk to each other so that like you can make a change in the web interface and it's going to like sort of, add something into your column, or, add a column in or add something into your evidence table. Basically, because everything is backed by a relational database, things that can be filled in automatically. The way that things are sort of associated with each other is maintained within the data storage representation. And you can build an automation on top of that instead of having to sort of like manually transition back and forth between these tools. That's at least sort of the idea that I had in mind.
Thanks for the answer. Betsy Wolf has a comment talking about uncertainty to the general public and challenge of doing more complicated models with relatively small sample sizes. I don't think it's a question, but yeah. And Dongji Wu has a question. I wonder how we can access the MetaExplorer tool.
So there is the code is open source. There is a link to the tool on the GitHub repository, which I do not think it's gone stale. Basically, the status of the tool at this point is that it's living on the internet sort of as a demo. It's attached to a Firebase instance, so like the data is stored in the cloud or whatever. I would think that in order to use it, the best bet would be to clone the code, attach it to your own database, and go from there. It's not hosted in a way that it could support a broad base of users at this time. If there's an interest in doing that, that's something that I could stand up. But I think there's maybe more mileage to be gained from iterating on this idea, creating something that has sort of fewer gaps in its functionality, and then trying to make that thing more sort of fully supported to try to have a user base. My sense is that this is not quite what people wanted, I guess is what I'm saying.
Another question from Rebecca: do you offer users sample text for how to talk about the processes they have gone through in MetaExplorer, and i.e. how to write up the sensitivity analysis and other steps?
That's a really interesting question and not something that anybody has asked me before. So I mean, the answer is no, but it's a good idea. That part of sort of the output should be an explanation of the process. That's a really interesting idea. Thank you.
No problem.
Another question from Dongji: will you develop a program or an app later on?
I'm hoping to. It's really, as is often the case with building technology for research, it's you have a student who's really interested in working on this thing and capable of executing it, and you manage to wrangle some funding to make it happen. And so it's something that I'm interested in. It's certainly my motivation for coming to give this talk is feeling that I learned a whole lot about this interesting topic and this very pressing set of challenges. through the work that I presented today, and that I would like to sort of, I would like to do something else in this space. I would like to distill that into something more usable that is more feasible to like maintain and build a user base for. That is my sort of intention.
Question from Yuha. Would love to hear your thoughts about prospective meta-analysis. In essence, this is a method where the protocol for meta-analysis is prepared before the results of the studies to be included are known, ideally even before studies themselves are even conducted. It is said that this method may reduce biases and seems to be gaining traction in fields like medicine to ensure the reliability of results. Seems to be a promising methodology.
Yeah, so this is an interesting thought. I mean, it sounds kind of like like pre-registration for meta-analysis. I have to admit that I'm a little bit skeptical that you can specify everything in advance without sort of seeing the messiness of the literature. And I mean, maybe this is more feasible in a field like medicine where you have kind of like more standardized approaches, but I mean, like, even then, right? Like, you're going to have, sort of like lapses in your protocol. You're going to have things that didn't go the way that the study was planned. I just think that one of my controversial opinions, I think, about ideas in the statistical reform movement is that some suggestions kind of imply that in order to combat researcher degrees of freedom, we should just look at our data less, or we should, inspect the, peculiarities and idiosyncrasies less, that we should not let these things sort of drive our analysis, because as a virtue, it is bad to do things post hoc. I understand where that's coming from, but as somebody who works on data visualization, like, sometimes you could come to a data set with a brilliant idea for your analysis, and it could totally not work for your data. And you won't know why unless you visualize your data, unless you do something a little bit exploratory. So I think that kind of applies in this setting as well. Like, until you're looking at the mess that you're dealing with, it's really hard to say what you're going to do, at least completely. I certainly think that you could try to specify some sort of guardrails. And I think that is in line with best practices in pre-registration, where you don't try to winnow down degrees of freedom in ways that you don't have the foresight to, but you try to say what it is that you're going to do to the greatest degree that you can.
Looks like Wolfgang's raising his hand.
Yes. Hi, Alex. Thanks for your interesting talk. I have a question about how to sort of address these issues around epistemic uncertainty. So you gave the example, let's say, of studies using different instruments, and you don't know if they're really measuring the same underlying construct. So one way of addressing this is sort of empirically, right? So we compare, let's say, the average effect size for studies using this type of instrument versus another one. And so just empirically, we sort of try to get an idea of whether these kind of things matter or not. So I'm sort of wondering, what are your thoughts on, can we just address everything empirically if we have sufficient data, of course, or are there other sources of uncertainty that really just require reasoning and thinking and discussing, or can we just address it all just empirically through numbers and models? And so I'm curious what you think about this.
It's a really interesting question. I think there are probably some of these challenges that you can address empirically, things where there's like a very clear link between a study design choice and sort of a like causal effect within your data generating process, right? Like, if you know that something induces a particular type of selection bias, if you know that something introduces an additional source of variance that wouldn't have been there otherwise, maybe you can try to get a sense of like empirically, how do those problems, accrue, and what methods of evidence aggregation are robust to them. I think where this starts to get tricky is like where you have that interacting with other idiosyncrasies in study design. And you end up in these situations where maybe you have very sparse information about this, particular interaction of factors, or maybe experts disagree on the extent to which a particular study design idiosyncrasy is a problem, and it becomes a lot murkier to tease apart like what is having an influence on what within this sort of like tangled skein of analysis choices that you're trying to sort of dissect. So maybe there are cases where we can like figure out like clear counterfactuals and identify best practices in light of that. But I think that for a lot of things, it's just messier than that. And our ability to resolve things in that with that kind of precision. I'm not saying that it's impossible in principle, but I think that we're really quite far from that.
I'm on that same sort of line. I wonder if this, if you've thought at all about useful ways of like representing the structure of study characteristics along these different dimensions of risk of bias and like relevance. I think it's something that systematic reviewers kind of struggle with, right? Like on the one hand, they just like report these gigantic tables of the risk of bias scores in each domain, study by study. And then on the other, you have people doing things like, adding the scores together up, adding the scores from each dimension into a scale, and then just treating that as a unidimensional predictor. And sorry, yeah, Terry's freaking out. Even mentioning that. I think so. So yeah, like ways of presenting the the tangled skein of different study characteristics.
It's a really good question. I think there are probably more novel visual representations than the kinds of like tables and lists and things that we categorization schemes that we tend to come up with. I think one of the challenges of producing sort of a more bespoke graphic to communicate something like this is then you have to grapple with the fact that it's unfamiliar to people who are going to be seeing it, that people don't necessarily know how to read a type of visualization that they've never encountered before. And so I think that it is a worthwhile direction for future research, but then we have to grapple with these questions about, okay, well, who are these visualizations for, and how do we teach people how to use them? So I can imagine something like that being like very useful as sort of like providing like an overview of what's going on in your review for someone who's like intimately familiar with the papers in that review, and they've been going through and they can connect these sort of abstract visual representations to like the like episodic memory of having gone through this paper and been like, yeah, I thought that was fishy. I don't know that something that tries to sort of like represent this like multidimensional space of issues in a really sophisticated way would carry the same meaning for like a member of the general public picking up the like sort of final result of something and trying to make sense of the uncertainty in the review, right? For that, you need like a different type of presentation.
For sure, yeah. So we have to think about the audience, but I think I think there would be a lot of demand, right, for tools like that or visualizations like that to help the reviewers themselves.
Yeah.
Also things like dimension reduction, right? Like, something I always wonder about, right, is like, if you're looking at these like risk of bias scores and relevant or relevance to the topic, whether there's like an underlying structure to them that's simpler than all of these different scores on all of these different dimensions. Maybe there's, I mean, like the best case scenario is like there's two latent classes, right? Good studies and crummy studies. In which case the analytic approach is like very, very clear. But like I think, but even if you're limiting it to kind of a research focused audience, I think it would be very useful.
That's a really interesting point. I think when I try to conceptualize what that latent space would look like, I think it would kind of separate out into different like sort of clusters of failure modes for research design. And that what that latent space look like is in some sense going to be like in reference to the target context that you're trying to make an inference about. Like, a set of studies could be, more or less problematic depending on what you're trying to do with them. And so I think you need some way of incorporating that consideration into the construction of the latent space. But dimensionality reduction is interesting. There was a big movement in visualization some years ago, a lot of interest in visualizing dimensionality reduction techniques. The trouble is that these spaces that get produced by dimensionality reduction algorithms have like inherently uninterpretable units. And that's something that I haven't really seen a satisfying solution to on the visualization side.
We are past noon here, and we try to keep the talks to an hour. So I guess we'll draw to an official close. And I'll offer once more really big thank you to Dr. Kale for great presentation. Looking forward to more work in this space.
Yeah, thank you.